Hi guys, welcome to my channel Civil Laces. I'm here with another video tutorial on building structures. In previous videos, we talked about types of slab and some basic things that you need to know about one-way slab and two-way slab. In today's video, we will talk about preliminary design of slab. So this is the plan of the building, and in this plan of building, there are different panels of slab. So they have different dimensions. We are not going to design every panels of slab, rather we are going to design the critical panel of slab. That panel of slab is critical, whose both dimensions is largest among all. So our first job is to identify the critical panel of slab from the plan. To find the critical panel of slab, you need to find the largest value of center to center distance of grid in both x directions and y directions. So at first I'm going for the x directions, and these are the value of center to center distance of grid. So if I see here from this point to this point, I'm seeing that this 21 feet 6 inch is the largest distance amongst all in these directions. The distance between D grid and E grid is 21 feet 6 inch, which is the largest among all the values. Similarly, let's move on to the Y directions. And if we see here, this 24 feet 5 inch is the largest distance among all the grids. That is, the distance between 3 and 4 grids has the largest value among all the grids. So the panel of slab that is critical is formed by D, E and 3, 4 grids. Basically, this D, E and 3, 4 grids coincide to this panel of slab. Thus, we find that this panel of slab is the critical slab that we are going to design. Simply, this is our critical panel of slab. So I'm going to copy this slab outside this plan. Let's draw a line over here. So I'm going to copy this slab outside this plan. I click and here. Here we have it. Okay, so this is our critical slab. So let's show the dimension to this slab. So this is the dimension of the slab. This panel of slab has length of 21 feet 6 inch in one direction and 24 feet 5 inch in another direction. This was our slab on plan, and you can see that this is continuous on all the sides. So our first job is to know whether this panel of slab is one-way slab or two-way slab. At first we have to check whether the slab is supported on all sides or not. So if you just simply see here, this slab is supported on all sides, because you can see there are 4 columns, and in every columns there will be the beams. Thus slab is supported on all the sides. Now we need to find the Ly by Lx ratios, that is length of longest span of slab to length of shortest span of slab ratios. And if that ratio comes below 2, then it will be a two-way slab, and if that ratio comes greater than 2, then that will be a one-way slab. So we need to find the Ly by Lx ratios. So we had length of longest span of slab Ly equals to 24 feet 5 inch. You can see that longest span of slab has length of 24 feet 5 inch. Similarly, the shortest span of our slab has length of 21 feet 6 inch. So Ly equals to 24 feet 5 inch, that equals to 7442.2 mm, and Lx equals to 21 feet 6 inch, that equals to 6553.2 mm. So if you find the Ly by Lx ratios, you get the value of 1.135, and which is most importantly less than 2. Thus, it is two-way slab. Now, let's see the procedures of preliminary design of slab. Basically, the preliminary sizing of structural component is done with the help of span by depth ratio. The basic concept is we have span. So if we have span by depth ratio, then we can find the depth of slab. According to IS code, the basic value of span by depth ratio equals to 26 for continuous beam or slab. We already knew that from the plan, our slab is continuous on all the sides. You can see again here, our slab is continuous on all the sides because this is an interior slab panel. So you can see the IS code here. Basic values of span to effective depth ratio for spans up to 10 meter is, for cantilever slab it is 7, for simply supported slab it is 20, for continuous slab it is 26. It is applicable to both beams and slab. So we call this basic value given by IS code as alpha, that is, for our case, the alpha equals to 26. There are certain modifications that you can use greater value than this value depending upon the conditions that you have. So this is the basic value of span by depth ratio, which is 26 for continuous beam or slab. And you can use the limiting value of span by depth ratio for preliminary sizing, which is equals to this alpha, that is 26 times beta, gamma, delta, and lambda. These beta, gamma, delta, and lambda are the modification factor. And simply this beta is span factor. And you can see here, for spans above 10 meter, the values may be multiplied by 10 by span in meters, except for cantilever, in which case deflection calculation should be made. We have our spans less than 10 meters, so automatically the span factor will be 1. That is, for span less than 10 meter, beta equals to 1, since beta is the span factor. Similarly, this gamma is the tension reinforcement modification factor, and you can see in IS code that this is a modification factor called gamma, in which considers the percentage of tension reinforcement. We haven't designed our slab yet, so we don't know actual percentage of tension reinforcement in our slab. But we can say from the experience that the percentage of tension still in slab is more about 0.2 percentage. So you can see this curve in IS code at page number 38 of IS 456 code, that to find the modification factor for tension reinforcement, you need to know two things. The first thing is percentage of tension reinforcement, that we have already assumed of 0.2 percentage tentatively. And you need to find the Fs. These are the curves of Fs. And Fs is given by this formula, that is 0.58 times Fy times area of cross section of steel required divided by area of cross section of steel provided. We are just trying to find the tentative value of Fs, and here we are using HYST 500 grade rebar. So the Fy will be 500 MPa. Suppose we are using the exact amount of steel required. I mean to say area of cross section of steel required is equal to area of cross section of steel provided. In that case, Fs will be 0.58 times Fy, and 0.58 into 500 equals to 290. So we are using the 0.2 percentage of tension reinforcement, and this Fs equals to 290 curve. So if I draw a straight line over 0.2 percentage of tension reinforcement line and this Fs 290 curve, they meet at this point, and tentatively its value is equal to 1.4, because this is 1.2, this is 1.6, and in between them there is a value of 1.4. So we say that the modification factor for percentage of tension reinforcement is 1.4. The gamma is the tension reinforcement modification factor, which is equal to 1.4. And this del is the compression steel modification factor. We generally assume no compression steel on slab, so del will be 1. You can see here modification factor for compression reinforcement, and if percentage of compression reinforcement is 0, then we can apply 1 as a modification factor for percentage of compression reinforcement. And another factor is that lambda. Another factor is this lambda. So this lambda is the reduction factor that considers the whether the section is flanged or rectangular. If you see IS code at page number 39, depending upon the ratio of wave width to the flange width, reduction factor is found out. Since the slab is a rectangular section whose wave width to flange width ratio is 1, that is simply for rectangular section the reduction factor will be 1 because ratio of wave width to flange width will be equal to 1, and for 1 you can see the value of reduction factor is 1. So lambda is the reduction factor that comes into the consideration when you have flanged section. Since slab is rectangular section, lambda will be equal to 1. The basic value of span by depth ratio was 26 for continuous beam or slab, but I already said we can use higher value than this depending upon our condition. Now finally span by depth equals to this basic value 26 into beta span factor. Since our span is less than 10 meter, we can use 1 into gamma is a modification factor for tensile reinforcement, which we found out 1.4 from the graph in IS 456 code. Del is a modification factor for compression reinforcement, which we assume there is no compression reinforcement on the slab because there is never a significant compression reinforcement on the slab. So we assume a value of 1, and slab is a rectangular section, so reduction factor will be 1. Ultimately, the span by depth value comes as 36.4. So we can use this 36.4 span by depth value to find the depth of slab. If you have watched our previous videos, you understand a thing that slab always bends on shorter side. Since more slab loads are transferred to the longer edges, slab always bends on shorter side. So just make sure that you watched our previous videos. Since slab bends on shorter side, the slab span that we use here in this formula should be of short side. And this was our critical slab. This was our critical slab, whose one dimension is 21 feet 6 inches and another dimension is 24 feet 5 inches. Ly equals to 24 feet 5 inches and Lx equals to 21 feet 6 inches. Ly by Lx ratios, that is 1.135 less than 2, thus it is two-way slab. So to know more about one-way and two-way slab, please check our previous videos. We already have span by depth equals to 36.4 from here. Now we used span value of 6553.2, that is slab always bends on shorter side, so the span value that we are using in this formula should be a shorter side span value, that is this 6553.2 mm. And to find depth, this span is divided by 36.4, which comes 180.03 mm. But you know, the depth of slab should not be greater than 150 mm. The reason is it is difficult to cast a greater depth slab than 150 mm. So we have to restrict the overall depth of slab to 150 mm. In this case, effective depth of slab comes 180.03 mm, which is greater than 150 mm. So in this case, we should add secondary beam to reduce the slab depth. It means we have to decrease the slab depth to 150 mm or even less than that, because the depth come after using this formula is the effective depth, and to find overall depth we have to add cover and half of reinforcement value. Simply we are just playing on this formula, that is span by depth equals to 36.4. To decrease the depth we have to reduce the span, and span is reduced after the addition of secondary beam to the slab panel. Now let's see here. We generally have two options to add secondary beam, that we can either add secondary beam parallel to the longer edge, or we can add secondary beam perpendicular to the longer edge. We have that two options, but you need to remember the fact that we can never place a secondary beam that is parallel to the longer edge. For example, if you add the secondary beam that is parallel to the longer edge, for example, I'm going to say if you add a secondary beam parallel to the longer edge. So here I'm adding a secondary beam that is parallel to the longer edge in this way. Now the slab panel is divided into the two panels. Let's give the dimension of this edge. So this is 10 feet 9 inches. So our critical slab panel becomes this panel or this panel because they both have same dimensions in x directions and y directions. I'm just showing you why that we can't keep a secondary beam that is parallel to the longer edge. In this case, one dimension of slab is 24 feet 5 inches and another dimension of the slab is 10 feet 9 inches. Now, if we do the Ly by Lx ratios, that is 24 feet 5 inches divided by 10 feet 9 inches, it comes as greater than 2. So, if Ly by Lx ratio of slab is greater than 2, then it will be one-way slab. We should never intend to design a one-way slab, or we should never intend to create a one-way slab in building. If you create a one-way slab by adding secondary beam in parallel to the long edges, then larger loads will be transferred to one direction edges and it will be not good for the design. I hope you understand this. So I delete this line and give secondary beam perpendicular to the longer edge. We now have these two panel of slab. They are similar, that is they are identical. So either this is our critical slab or this is our critical slab. So let's give this dimension, which is 12 feet 3 inches. So this is our panel of slab whose one length is 21 feet 6 inches in one direction and another length is 12 feet 3 inches in another direction. Thus, new slab panel has a dimension of Ly, that is greater length of 21 feet 6 inches, which is equals to 6553.2 mm, and Lx 12 feet 3 inches, which is equals to 3733.8 mm. Ly refers to the larger length of slab and Lx refers to the smaller length of slab. So if you do Ly by Lx ratio, then it comes 1.75. See, if you place a secondary beam perpendicular to the long edge, then the created slab will always be two-way slab. So you need to remember a point that the secondary beam should be perpendicular to the longer edge. We already have span by depth value of 36.4 that we have calculated here, 36.4. Now depth equals to span by 36.4. And I have told you already that the span we use in this formula should be a short side span because slab always bends on shorter side. Since larger loads are transferred to the longer edges, slab always bends on the shorter side. The shorter side length was 3733.8 mm and it is divided by 36.4, which is equals to 102.6 mm. This is not overall depth of slab, rather this is effective depth of slab. So to find the total depth of the slab, you need to add effective depth of slab plus, I assume we are using 12 mm dia reinforcement bars on the slab. So half the length of 12 mm is 6 mm plus concrete cover of 15 mm. The value comes is 123.6 mm. Thus, let's take overall depth of slab equals to 125 mm. In this way, we give the preliminary sizing of slab. I'm doing a project on this, so I just wanted to define this obtained preliminary size of slab in ETABS. For that, go to define and then section properties and then slab section. a new property, and I want to define its slab 125 and thickness should be 125 mm. Okay, I hope you guys understand the preliminary design of slab, and in another video we will talk about preliminary design of beam and column. And guys, I'm very close to 500 subscribers on this channel, so if you haven't subscribed this channel, please subscribe the channel, do like and share with your friends. Thank you.